Health Watch, scientists have been debating how the coronavirus spread since the pandemic began last spring. Those conversations have been heating up recently as some experts argue that aerosols may in fact be playing a bigger role in its transmission than previously thought. Earlier, CBS News chief medical correspondent Dr. Jon LaPook spoke with a few experts about how the coronavirus travels through the air and how to best protect yourself against it.
There's been a lot of discussion and controversy over how SARS-CoV-2, the virus that causes COVID-19, spreads. You've heard terms like droplets and aerosols, and you may be wondering, what in the world is an aerosol? Well, fortunately, we have two world experts in this, two aerosol scientists, and they, along with aerobiologist and physician Don Milton, have been helping me over the last few months to figure out what is going on from an actual physical point of view. So I'm going to let them introduce themselves, and I'm going to start with Linsey Marr. The other person is Kim Prather. And Linsey, can you introduce yourself and tell everybody what exactly you do and what an aerosol scientist does?
I'm a professor of civil and environmental engineering at Virginia Tech. I happen to study viruses in the air. It's one part of being an aerosol scientist. You've probably heard of particulate air pollution, the stuff that's generated by wildfires and burning diesel and other fuels. Well, that's what aerosol scientists study, the chemical composition of that and how it moves around in the atmosphere and what its impacts are on the environment and our health.
Terrific. And Kim Prather, tell us what you do and what your research is concentrated on.
I'm Kim Prather. I am Distinguished Chair in Atmospheric Chemistry at UC San Diego, and I also study aerosols. I study different aerosols. I actually look at microbes, viruses, bacteria, and what comes out of the ocean. And so I look a lot at sort of how biological particles float around in the atmosphere. I also look at air pollution, but in the end, I'm very interested in how aerosols influence both our climate and in human health.
And I'm very grateful to both of you and also to Don Milton for giving me an education over the last few months about exactly what's going on in terms of aerosols and droplets. I don't want to make this too wonky. I don't want to go down the rabbit hole, but I do want you to sort of tell us, set up where we are right now. What do we know about the way this virus might spread through the air?
So what we know right now is that it is this SARS-CoV-2 virus that leads to COVID-19 can be spread in sort of aerosols and droplets that come out of your mouth. We normally think of diseases, coughing and sneezing. In this case, just speaking, you produce thousands of aerosols. And so these aerosols the aerosols basically can float through the air, and the droplets, the aerosols sort of behave like cigarette smoke. The droplets will settle quickly to the ground within 6 feet. And so we're very interested in the aerosol part because these are the ones that can build up in the air and lead to people inhaling them and becoming sick.
What's all the controversy about, Linsey?
There's been a lot of controversy about whether the virus spreads through the air, because initially people thought that it spread mainly in large droplets that you can see and that fly out of your mouth like mini cannonballs and land in the eyes, nose, or mouth of someone else. But what we've learned is that virus is also being transmitted in much smaller droplets, microscopic ones that we call aerosols. And for every one large droplet that you might see, there are hundreds or thousands of smaller ones that you can't see. They come out of our mouths just like cigarette smoke from a smoker, and they're very concentrated close to a person. So when we talk about transmission happening in close contact, it's not necessarily large droplets flying through the air. It's most likely the smaller ones, the aerosols that we're breathing in when we're in these close contact situations.
And the reason why this isn't just scientific mumbo jumbo, which who knows what it really means, it does have significance. And the reason is that if we're thinking about spread within 6 feet, we keep hearing 6 feet is an important distance for social distancing. And there may be spread via these droplets, these cannonballs within 6 feet, or via aerosols within 6 feet. In fact, it makes sense, right? You've explained to me that if you have it floating through the air, the closer you are to somebody, the more concentrated. The issue becomes controversial when you get past 6 feet, because we've heard recommendation that if you're past 6 feet, and let's talk about indoors first, that maybe you don't need a mask indoors past 6 feet because it's really the 6 feet that matters. And what you're telling me and what other people are saying is, wait a second, it can float past 6 feet. We may not know exactly to what extent the aerosols that float past 6 feet contain viable, live, virus that can infect you. We may not know the extent to which, if it happens, it's actually significant in terms of how many people get infected. But if it's happening at all, then we need to think about it indoors. Right, Kim?
Yeah, I mean, indoors is the place that we've seen, cases in restaurants and the choir practice in churches. And it's a place where, just think about going back to the analogy of cigarette smoke. If you're in the room with a smoker, just one smoker, over time, if the room's not properly ventilated, the air, it will just start to become more and more filled with smoke. And from being with a smoker, you could be pretty far away from someone and smell their smoke. And that will just build up and accumulate over time.
And in case people haven't heard about it, the choir super spreader event that you're talking about is this famous case in Washington State in a choir practice where one person apparently affected 52 other people. And it just didn't seem logical that that could have all been from either touching some infected surface, so-called fomite spread, or by the person being within 6 feet of 52 other people. So that brings us to, okay, the significance of the fact that it could be spreading inside a room says to us, okay, and you've explained this to me, Kim, now that we know, if we accept that there is a possibility that this is an important way or a contributor, whether it's 1% or 5% or more, whatever the percentage, don't you want to do something about it? And what are the fixes? I want to go to you first, and then I want to talk to Linsey about masks, because that's something that she has real expertise in. So Kim, you go first.
Yeah, so I mean, I'll leave the masks. Masks are, if you make me pick one thing, I'm going to say masks, but Linsey will talk about that. But just once it's in the air, and once we know that air, we share the air, we all breathe the same air in a room, and that's when we see these events where 90% of the people catch it. Once we know that, it's a very fixable problem. We can filter the air, we can add better ventilation, you can open the windows and the doors. That's the simplest and cheapest thing to do. And we can spend more time outdoors. Keeping distance is still important, but there's so many things you can do to clean the air. Once you acknowledge it, it is in the air.
Great. And then I'm going to turn to Linsey to finish it up about masks, as everybody has a lot of questions. And I'm just going to have it as an intro to this. We know from epidemiologic data that countries that use masks have fewer infections with coronavirus, with fewer COVID-19 infections. They seem to be getting their arms around the problem better. But that's sort of indirect evidence, because they could be doing other things. We also know in the United States, in Missouri, there was a case that was reported by the CDC that back in May, there were 2 hairdressers who turned out they were sick. They had COVID-19 and they were seeing clients over about a week. They were wearing masks and they saw 139 clients, and the number of people who got symptomatic COVID-19 was 0. They were able to test about half of them, and none of them had the virus. So that's really good evidence that the masks are doing some good. And incidentally, one of the hairdressers went home and was not wearing a mask at home and infected 4 people she was living with. So there's sort of the controlled experiment you would never do in real life. Linsey, tell us about masks. What's the evidence that they really do work?
Well, there was another study I want to point out looking at different states and localities in the U.S. which implemented mask mandates at different times, and they found that that did have an effect on the number of cases. There was a slowdown in the number of cases. They bent the curve after implementing those mask mandates at different times. So masks work because they physically trap the virus. So if you happen to be sick and you're wearing a mask, it prevents the virus in those droplets and aerosols from escaping. Maybe a few of them escape, but a lot fewer than would be otherwise. If you're wearing the mask and you are in an environment where there's lots of virus in the air, the mask can block viruses and these droplets and aerosols from getting into your nose and mouth. And the way masks work is they're not like a sieve. It's not like a sieve where you put your pasta in and it catches the pasta and the water goes through. The virus is small, but it's in droplets and aerosols that are larger than the virus itself. So we need to worry about blocking those. And the way that the mask blocks those, again, is not by having them too big to fit through the holes, because we know that there are holes that are bigger. But what happens is that if you imagine that you're running through a very dense forest, and the trees are spaced closely enough that if you're going slowly, you can walk slowly around the trees. But if you're trying to run full speed through that forest, you can't follow the path around the trees. So that's what's happening with the viruses. They can't follow the airflow around the fibers in the mask. They end up crashing into the fibers, and they get removed.
Got it. And sometimes we can't see the forest for the trees here in this discussion. And I should just point out in closing that the reason why masks are being recommended when before not so much was because of the discovery that there was a lot of asymptomatic spread. So you couldn't rely on people being sick to say, okay, that's when they're spreading the virus. Once we found out they were spreading it when they weren't sick, then masks became something that that most people in science were recommending. Thank you so much for this really interesting discussion. I could go on forever and ever. Linsey, Marr, Kim Prather, thank you so very much.
Thank you.